Hi, this is Sue McBride, and this PowerPoint will cover section 2.3 in the textbook Statistical Reasoning for Everyday Life, discussing the use of percentages in statistics. We will be using our calculators again, so make sure you have one handy. We're going to continue with our goal of working with vocabulary and how it relates to percentages in particular, and how they're used to report statistical results, as well as recognize the way they can be misused, which is a lot. So one of the goals of this course is to make you a more educated reader in terms of the statistics you see in your everyday life. That's why we like this new textbook we choose. Alright, so let's do a little bit of review on how to convert between fractions and percentages. This is something you would have worked in Module 2, MTH2, was taking a fraction and turning it into a percent by going through the decimal stage. So to convert a percentage to a common fraction, you replace that percent symbol with divided by 100, or put a bar over 100, and then simplify that fraction if necessary. So in your section notes where it has example, this is the example I want you to put, or you can use the one from the textbook if it's different. So 25%, I drop the percent sign and put the divided by 100, and then I reduce that to 1/4. Now to go from a percentage to a decimal, we're going to drop that percentage symbol and move the decimal places 2 places to the left. In other words, you're dividing by 100, but the fast way to do it is divide it. I move it 2 places to the left. So 25%, the decimal place is understood to be behind the 5, even though it's missing. So I'm going to drop the percent sign and move it 2 places to the left. You don't have to put the 0 in front, but a lot of people do to indicate there's no whole numbers and you've got 0.2. Alright, so now if you want to go from a decimal back to a percent, this time you're going to move the decimal places 2 places to the right and add the percent symbol. Some people remember that by going, oh, the percent is on the right of the number, so I move the decimal places 2 places to the right. It goes towards where you're going to put that percent symbol. So 0.43, I'm going to go 2 places to the right and add my percent sign. And notice there's no decimal in the 43 because there's no decimal places behind the 3. Now if I want to go from a common fraction to a percent, I have to do my intermediate step. I'll change the fraction to a decimal first by dividing the numerator by the denominator, then convert the decimal to a percentage by moving it 2 places. Remember from the last lesson, if you want to round that percentage, you would move the decimal place first and then round to the nearest whatever. So 1/5, if you divide 1 divided by 5, you get 0.2. Now I have to move my decimal 2 places to the right, and this time I'll have to add that 0 in because I'm missing it. So I have to add it in to get my 20%. So how do I use percents? Alright, if you notice on your section notes, it reminds you that if you have the percent of something, you're going to multiply. So if a newspaper reports that 44% of 1,069 people surveyed said the president's doing a good job, if I want to get the actual number, I'm going to multiply the percent by the total, but I have to remember to move my decimal place first. So I convert it to 0.44 and then I multiply, and because we're looking at people, I can't have 0.36 of a person, so it's common sense to round this to the nearest person. So using your rounding rules, because 0.3 is less than 5, I just drop it and keep my 470. So about 470 out of those 1069 people say the president's doing a good job. So notice, again, we did round to the whole number of people, and that wiggly equal sign means approximately equal to. It lets us know that you rounded. The exact answer has the straight equal. The rounded answer has the wiggly equal, means approximately to. Alright, so how can I use percentages to describe change? We have 2 phrases here. One's called absolute and one's called relative. And these are the same vocabulary the same vocabulary you used with error. So when we do an absolute change, it's going to be the actual increase or decrease from a reference value to that new value. A reference value is going to be the one you started with. So absolute change is whatever your new value is minus that reference value, the one you started with. So a relative change, just like when we did a relative error, describes the size in comparison to something. So we express it as a percentage. So the relative change describes the size of the absolute change in comparison to that reference value. So when we compare, we're going to write it as a fraction and then convert that fraction to a decimal and then to a percent. So relative change will be that new value you get minus the reference value, the one you started with, divided by the reference value. And then you'll multiply that by 100%. Actually, you multiply it by 100 to keep percent. So this is time out to think is what I was just pointing out. These formulas should look very similar for absolute and relative error versus absolute and relative change. To get the absolute, we take the new one and subtract the true one for error. Here we take the new one and subtract the reference one, the one we started with. So relative error, same thing. We found the absolute and divided by the true one to get us our our relative error. And when we do our relative change, we'll do the same process. We'll find the absolute and then divide it by the reference one, the one we started with. So in errors, you call it the true one. In change, you call it the one you're starting with, is your reference one. All right, so here's our world population was 2.6 billion in 1950. It had grown quite a bit by the year 2000. It had reached 6 billion. Wow. Describe the absolute. So absolute we're going to be subtracting. Relative we're going to be dividing. So to get the absolute, we take our new value of 6 billion and subtract that thing called the reference value, the one we started with, to get 3.4 billion. To get the relative change, we need the absolute change, and then we will divide by what we started with called the reference value. So relative change is absolute change, which is new value minus reference value, divided by reference value, or what you started with. So 6 minus the 2.6. So notice you divide it by what I call the original value, the reference value. It's the one we started with. Then once I get that number, I move the decimal over 2 places and add the percent. So our world population has increased by 3.4 billion, which is the absolute change. But if we want to look at that in percentages, that's about 131% from 1950 to 2000. So the next thing we want to talk about is what does it mean when we have these numbers bigger than percent? Just a little bit of interesting tidbit. So according to the United Nations and U.S. Census Bureau estimates, world population passed 6 billion in late 1999, only 12 years after passing the 5 billion. It's going way fast. If you're taking an algebra-based class, we usually call that exponential growth, where it's got a steep rise to it. It's not taking as long to reach the same value, so it's not doubling in the same amount of time. It's faster. All right, how can we use percentages for comparisons? All right, so these are commonly used to compare two numbers. So in this case, the two numbers are the reference value and the compared value. So in your notes, I put that in. So the reference value is the one you're starting with, and the compared value is the new one that you are going to be finding. So reference value is the number we're using as the basis. In other words, we're starting with it. The compared value is the other one, the one we compared to the reference value. Oops, not too far back. I wanted to go one back, was 16. So then we do 16 divided by 59. If you're using your graphing calculator, when you do a subtraction like this, you have to remember to put a parentheses, 75 minus 59, close the parentheses, then divide by the 59, and you should get 0.27 or 27%. So be careful how you put that in the calculator. Make sure you get that 0.27 and then convert it to percent. So in absolute terms, the life expectancy of American men is 16 years greater, but in relative terms, the American is 27% greater than the life expectancy of the Russian. So the Russians are what we started with. They were our reference value, and we were comparing the American men to them, so they were our compared value. All right, let's take another look at vocabulary. Of versus more than or less than can get really tricky. You have to listen carefully in the news reports and reading in magazines and internet, wherever you're reading. Be careful of the wording. When you have of, and they didn't mention this, of just means straight multiplication. So if I want 10% of 50, I just say, oh, 10%, 0.10 times 50 would be 5. 10% of 50 is 5. But as soon as I see the more than or less than, here I have to be careful because I'm increasing the percentage, so I have to add to it. And 100% is one total thing, so I'm going to add to 100 to get an increased percentage. All right, so to this definition, if the new or compared value is p% more than the reference value, more than the one that you started with, then you find 100 plus p parentheses percent of the reference value. If you look in your section notes, I put a little formula there for you. All right, so and an example. So you do parentheses 100 plus p percent times whatever that reference number was. So if you want to say 45 is 50% more than 30. So I'd start with 100 and add 50. So it would be 150% times 30 would give me the 45. All right. Conversely, if I want to say a new or compared value is p% less than that reference value I'm starting with, I'll now subtract from 100 because, again, 100% is one full thing. So if you look in your notes again, it says when we say that the quantity is a certain percent less than a reference value, we need to adjust it by subtracting the given percentage point. Or in other words, 100 minus p% times that reference value. So if I want to say 64 is 20% less than 80, then I would do 100 minus the 20, which would give me 80% times that 80 to give me 64. So be careful if you see the phrase p% more than, then I add it to 100 to get a number bigger. If I have p% less than the number, I'll subtract it from 100 to get a number that's smaller than my reference number. So always remember, if I am over 100, I'm going to be more than the reference. If I'm less than 100, I'll be less than the reference value. So in example 2, we found the world population was in 2000 was about 131% more than the world population. So because that's bigger than 100, we know that it's more than the original world population we were looking at. So how do I express this change with an of, which means a multiplication statement? All right, so my world population in 2000 was 131% more than the world population in 1950. So that'd be 100 plus my 131. So that's 231% of what I started with in 2000. So 2000 population is 231% of the 1951. So this means the 2000 population was 2.31 times the 1950 population. So I got a bunch of percents going on here, so let's take a look at that again. Remember, we got the 131% by comparing it to the world population in 1950. But going forward, I do 100 plus that 131% because it increased. The percentage was 131% more than. So now I have to add 100 to the 131 to get 231% of the, I have to keep checking their vocabulary. Again, this is a new book, and I will tell you that right up. They use some phrases that are a little different than I'm used to. All right, so just want to make sure I've got my right number here. They call it the reference value. Okay, so we do 231% of that reference value of 1950. So if I put that all together, that means the 2000 population was 2.31 times that 1950 population. All right, so let's think about this in terms of sales at the store. This is always interesting to me because if you know your math, sometimes you can catch the salesperson making a mistake here and get more off of an item than what they're trying to tell you. I've done this several times. So if you have one store advertising 1/3 off everything and another one says sales prices are 1/3 of the original, which one's having the bigger sale? Well, I would say the first one, 1/3 off of everything. So even if something was already on sale, you get another third off, or if it's an original price, you get another third off. But if it says sale prices are 1/3 of the original, they always start with the original. So you've seen some of those stores where they have a sales where it keeps taking off, like half of the original and then 30% of the new and 20% of the new. Those are the good ones. They're not taking it off the original, they're taking it off the already reduced prices. All right, percentages of percentages. Okay, so there's two ways you could talk about percentage. You can have percentage points versus the actual percent itself. So when you see a change of difference expressed in percentage points, then you can assume it's an absolute change. In other words, you're going to be adding or subtracting percentages to percentages, and they call those percentage points. If it's expressed as a percentage itself, then it's a relative change. In other words, you're dividing something to get that number. So the absolute change with the percentage points, you're going to be adding or subtracting. If you have a straight percentage, it's a relative change, so you're going to be dividing. All right, so based on interviews with a sample of students at your school, you can conclude that the percentage of all students who are vegetarians is probably between 20 and 30%. Should you report your result as 25% with a margin of error of 5% or as 25% with a margin of error of 5 percentage points? All right, now remember when we did margins of errors, we added and subtracted. So in that case, we know it must be the absolute difference because we added and subtracted to get it. If it was a percentage of it, then you would take 5% of 25%, which is not what was meant. So because you added or subtracted, it was an absolute value, so we use percentage points versus plain percent. Well, all right, so the first slide on percentages, we have last year's budget for the legislative branch was $49.19 million, and this year it's $53.33. Consider last year's budget of $49.19 as the reference value. So what's the absolute change going to be? Well, that just will be my new value, $53.33, minus my reference value, $49.19, for a change of $414 million, absolute change. The relative change, therefore, will be that absolute change of 414 divided by, remember what I started with, which was 49.19, or 0.084, or 8.4%. Question C says next year's budget is estimated to be 51.85. What's the percent decrease from this year's budget? All right, so again, I want the decrease, percent change, would be the 51.85 minus my 53.33. So I take my new value minus my old value and divide it by the old value. That's how I've always learned this. It's how it sticks in my head better. New minus old divided by old. And that gives you negative 0.028 or negative 2.8%. So there was a decrease of 2.8%. So for Part D, if next year's budget is changed so that it is 5% less than this year's budget of 5333, what would the amount be? All right, so now remember, this is a less than, so we're going to take 5% of the 5333 and find out that's 266.65 million. So I'm going to subtract that off, so my new budget would be 5066.35. Let's see. Question 10 is just a little bit of practice on expressing numbers in the forms of fraction, decimals, and percents. So you can see the correct answer next to those. So give those a try and then check the answer to the right. All right, number 18, we have car sales. In the current month, you have 18,830 Toyota Camry cars were sold, and there were 18,341 Honda Civics sold. So I would want to, sorry, I had to go find the textbook and look at the directions. All right, so for number 18, they just didn't give me enough information in the part that I had cut and pasted in there. So if you look on page 64, the directions say we've been provided two values. For each pair of values, use a percentage to express the relative change or difference. Use the second given value, that's what I was looking for, as the reference value, and express results to the nearest percentage point, and then write a statement describing the results. All right, so the second value is the reference value, which would be our Honda Civic cars. So we want to take our Toyota Camry and subtract our Honda because we're comparing it to the second value. So we'll do the Toyota minus the Honda and divide it by the Honda. That's going to be our formula. And I always like to write in the words of the actual problem. So remember, we're doing compared minus reference divided by reference. And they told me the reference was the second one. And we're comparing it to Toyota to Honda. So Toyota minus Honda divided by Honda, and that's how we get the numbers that are in the solution. So that's your 18,830 minus your 18,341. Notice the parentheses, divided by the Honda, which is your 18,341. There's your division. Make sure you get that on your calculator and then convert it to percent. So the statement you would make is, remember, we were comparing it, the Honda to the Toyota. I said that backwards. We're comparing the Toyota to the Honda, so you would say that Toyota sold 3% more than the Honda. The first one that compared comes first. So the Toyota Camry sold 3% more than the Honda. It's the thing that comes first, so we'll start the sentence with that. Try to find a way to make that make sense to you. So the Toyota sold 3% more than the Honda. Okay. If you want to pause it and try number 19 without looking, go ahead and do that. You know, hit the slide. It should, if you click on the slide, it should pause it. Okay, so hopefully you figured this one out. All right, so we have Chicago O'Hare Airport handled 67 million passengers last year. As the busiest airport in the world, Atlanta's Hartsfield Airport handled 89 passengers per year. All right, so we're going to do, this time we want the Chicago, which is 67, minus our 89, which is our Atlanta, divided by our 89. So we want our compared minus reference divided by compared. Or sorry, all right, you guys are going to get mad at me. I'm sitting here looking at the formula and I'm saying it wrong. Compared minus reference divided by reference. So compared would be, as I said, our O'Hare minus Atlanta divided by Atlanta. So 67 minus 89 divided by 89 gives me my negative 0.25. So the one we started with was our O'Hare. So O'Hare handled 25% fewer than Atlanta's Hartsfield. So compared minus reference divided by reference, and then your sentence is going to be you start with a compared one. So this time we would say O'Hare handled 25% fewer than Atlanta's Hartsfield. We're going back to number 12 since it had a bigger cut and paste. I couldn't fit it on the other page in the order, so go back to percentage practice. All right, so here we had a study conducted to determine whether flipping a penny or spinning a penny has any effect on the proportion of heads. So among that many trials, this many involve flipping pennies and that many involve turning up heads. The other 20,422 trials involved spinning, and 9197 of those turned up heads. Got it. All right. So what percentage of the trial involved flipping pennies? So we have a total of 49,437 trials. Of those, 29,015 were flipped. So that's how you would get that percent, divide, and get the 59%. You do the same thing for what percent were spinning pennies. Oops, pause and cough. Okay, sorry. All right, so we do our 20,422 divided by our total, which gives you 41% involved spinning the pennies. Now, they switched questions on you. Among the pennies that were flipped, what percentage turned up heads? So this time your denominator is just going to reflect the pennies that were flipped, which were 29,015, and of those, 14,709 turned up heads. So be careful, you're dividing by a different number here. So you would divide the pennies that were flipped that turns up head divided by the number of pennies that were flipped. Part D, same idea. Among the pennies that were spun, what's the percentage that turns up heads? You would have the denominator as the pennies that were spun, and the ones that were spun that turned up heads would be your numerator. So your 197 divided by your 20422. All right, and you can see the correct percent there. So your denominator is the total you're looking at, and your numerator is how many successful things were there. All right, let's go on to 22. Interview mistakes. Let's see, do I have a different set of directions? Yes. So if you look on page 65, here it says some important analysis of survey requires the actual number. So that's what we're working on here. We're finding the actual number. So here we want to know a survey of 150 executives, 47%. The most common interview mistake is to have little or no knowledge of the company. So those of you who are going on interviews, that's an important piece of information. Always research the company and find out stuff about it, ask some questions about it. Look like you are interested enough to look them up. All right, this is just a straight of problem. We want 47% of 150. So we just multiply and then we state our result, which you can see. Same idea for 24. Here we have 89% of our 9,132. So we'll multiply and then state our result as shown. Now 26 is a little different. If the area of Norway is 24% more than the area of Colorado, then Norway's area is what percent of Colorado? Right, so this is the one where we're adding to the percent. So if it's 24% more than, we add 100 plus 24 and say Norway's area is 124% of the thing it was being compared to, which is the Colorado area. And last, the vice president's salary is currently 42% less than the president's. So the vice president's salary, notice the answer's in percent. So I know I'll just do 100 minus 42, which is 58%. So the vice president's salary is 58% of the president's salary, which is what we were comparing it to. All right, we're starting to get into some math here. I would like you to go do your homework, and if you have questions, please email me. Have your calculators handy. We haven't used the graphing calculator specifically yet, but we will be getting to that. So if you still don't have your graphing calculator, you'll want to purchase that for when we start doing some statistical analysis in the near future. All right, thanks. Email me with questions. Bye-bye.